I told Claude to vibe code me an app. We're going to call it CargoCats. Here it is. It is a global shipping app. You can track shipments. You can manage addresses, vibe coded for our convenience. And I am going to show you how bad it was at actually writing secure code. All right, so I had Claude vibe code an app, and now it's finished with a security review. And as you can see, it's only found 10 vulnerabilities. Now I know we put in more. We actually put in 43. This was a purposely vulnerable web app. We put 43 vulnerabilities and it only found 10. Still not great. All right, so now that I've uploaded the good addresses, I'm going to upload bad addresses. Inside this bad address file is a payload that actually exports the entire database to a hacker-controlled domain. Back into downloads, I'm going to find a different file this time called payload. I'm going to open this one. Now this is interesting, right? Because the app says import failed. However, under the hood, it didn't fail. It's actually spitting out all of these addresses to an attacker right now. How many times will your app actually say like hack succeeded, and you'll get a nice message that says like, hey, your addresses were good, but your hack succeeded, so you're good. So no, that never happens. What you would look at is your logs, your application logs, your WAF logs, maybe EDR logs if you have them. But I'm going to show you something. We're actually going to find those logs in the console that I'm about to show you. In the logs, you will see there are no traces of a hack. And so if you have a WAF, if you have an EDR, those logs are insufficient because the attack that I just put in to CargoCats was only executed at the application layer. Now let's take a look at the attack in contrast. This is probably the coolest thing I'm going to show you today. It's all the details about the attack, not just where it came from, but where it actually was successful. It tells me the application name, the server name, and all the request details I would ever want. Oh my goodness. And the most important part here is what actually happens. So the method start in the file java.lang.process_impl was the culprit. It took, and I'll just tell you what happened in the attack. It took a deserialized object, and inside that deserialized object, that file, that payload.ser, included a payload that said, create a new file, write to that file with all the Etsy password information, and send it back out to an attacker. The reason why I know that is because in the stack trace, it shows me the exact line of code in the custom code that we wrote where that input validation failed. But if you had contrast, you would have seen 43 issues versus the 10 that Claude came up with security review. And if you didn't have contrast, you would have missed 33 issues. And not only that, you would have missed all the observations that come with it when you're attacked and if you've been exploited. All right, so now that we've turned on the protect rule for command injection, let's see if this actually works. Let's go back to import. We're going to import that payload one more time. There it is. Import failed. Deserialization attack detected. But notice that I actually never patched the code. I never went into my code base and said, add an input validation. I never actually did that. All I had to do was turn on the ADR protect rule. All I had to do was block it from ADR. That's so much easier because now I don't have to wait for my developers to go in and fix it, wait 2 weeks for a Jira ticket to be completed for some sprint. I can actually do it for them. I can actually block attacks for them without stopping their application from working. And that's so powerful because it gives your developers time to actually fix something on their timeline. And that's the power of ADR.